Did you know there's an animal in the deep ocean called the vampire squid, even though it isn't a true squid and definitely isn't a vampire? This small, ghost-like cephalopod drifts through some of the darkest, most oxygen-poor waters on Earth. Its name comes from its dramatic appearance, a cloak-like webbing between its arms, skin the color of dark wine, and eerie blue eyes that glow in the gloom. But rather than being a predator that sucks blood, it's a passive drifter that has adapted to one of the harshest environments on the planet, the oxygen minimum zone. The vampire squid inhabits depths of 600 to 900 meters, 2,000 to 3,000 feet, where sunlight no longer penetrates and oxygen levels are so low that most animals can't survive. This zone, called the oxygen minimum layer, is essentially an undersea desert for large predators. Yet the vampire squid thrives here by slowing its metabolism to a crawl and floating rather than swimming whenever possible. Its muscles and organs are built to extract every molecule of oxygen from the water, giving it an advantage in a place where competition is scarce. Despite its spooky name, the vampire squid is more like a living fossil. It belongs to its own order, Vampiromorphidae, a lineage that split off from octopuses and squids about 300 million years ago. That's before the first dinosaurs walked the Earth. Fossils of vampiromorphids show that these animals once lived in shallower seas, but over millions of years they retreated to deeper, darker waters as conditions changed. Today's vampire squid is the only survivor of that ancient branch, a single species representing an entire evolutionary experiment. Everything about the vampire squid's body screams deep-sea specialist. Its gelatinous flesh helps it withstand crushing pressures. Its huge eyes, the largest relative to body size of any animal, gather the faintest traces of light. Its 8 arms are linked by a black, velvet-like web that can invert over its body like a cloak, hiding its silhouette from predators. And instead of powerful muscles for hunting, it has thin, delicate arms and 2 long, retractable filaments used to gather drifting particles from the water. Here's the biggest twist. The vampire squid doesn't chase live prey. In an environment where food is scarce, it survives by collecting marine snow, a rain of organic particles falling from the surface. With its long filaments, it snags tiny bits of dead plankton, fecal pellets, and mucus, then rolls them into sticky balls and transfers them to its mouth. This passive feeding strategy requires almost no energy, perfectly matching its low-oxygen lifestyle. When threatened, the vampire squid doesn't release ink like other cephalopods. Instead, it ejects a cloud of bioluminescent mucus full of glowing blue particles, confusing predators in the pitch-black water. It can also turn itself inside out, wrapping its cloak over its body so only the spiny tips of its arms stick out, a behavior called pumpkin posture. Combined with near-motionless floating, this makes the animal almost invisible to hunters. The vampire squid's metabolic rate is the lowest of any cephalopod known. Its blood is rich in a special form of hemocyanin that binds oxygen tightly, allowing it to function where oxygen is at a fraction of surface levels. Its muscles are weak but efficient, and its neutral buoyancy means it doesn't waste energy swimming. All these adaptations turn it into a sort of living submarine drifting through the deep. Unlike many shallow water squid and octopuses that reproduce once and die, the vampire squid appears to have a more flexible approach. Females can spawn multiple times over their lives, releasing small batches of eggs instead of all at once. This is another energy-saving strategy. By spreading reproduction out, they increase the odds that at least some offspring will survive in the unpredictable deep sea. Bioluminescence is the vampire squid's secret language. Photophores, light-producing organs, dot its arms and body. It can flash, pulse, or fade these lights to startle predators, disguise its outline, or maybe even communicate with mates. In a world without sunlight, light becomes both a shield and a signal.